Attention! This channel provides original historical analysis based on sources and research. We do not simply recount events, we analyze their causes and consequences, explaining them through original narration, editing, and visual diagrams. A list of sources is included in the description. Enjoy watching. Welcome! Today we examine a decision made in October 1943 that violated military regulations, defied engineering doctrine, and saved thousands of American lives. This is not a story about generals or strategic planning. This is about a 22-year-old factory worker who refused to accept that men should die while waiting for official solutions. What follows is documented history, verified through combat records, engineering reports, and the testimony of men who survived because one sergeant broke the rules. October 14, 1943, 25,000 feet above Germany. The 8th Air Force loses 60 B-17 bombers in a single day. 600 American airmen dead. The mathematics are simple and unsustainable. Tail gunners, the bombers' last line of defense, achieve hit rates below 8%. At this rate, no crew will survive their required 25 missions. Senior commanders gather at headquarters. The defensive armament has failed catastrophically. Daylight precision bombing faces cancellation. But at that very moment, on a cold hardstand at Bassingbourn Airfield, a 22-year-old tail gunner with barely a high school education sketches a design that violates Army Air Force's regulations. A design engineers will call mechanically impossible. A design that will triple tail gun accuracy and save thousands of American lives. This is the story of the innovation they tried to ban and the gunner who refused to stop. The B-17 Flying Fortress enters combat in 1943 with a defensive philosophy borrowed from naval warfare. Bristling with 13 50 caliber machine guns mounted in powered turrets and manual positions, the bombers theoretically protect themselves through overlapping fields of fire and sheer volume of lead. Army Air Force's promotional materials call it a flying battleship. Newsreels show formations of fortresses, gun barrels protruding from every angle, supposedly impregnable to fighter attack. Reality proves brutally different. The defensive armament theory collapses upon contact with German fighter tactics. The guns exist. The ammunition feeds correctly. But the men behind those guns cannot hit their targets with sufficient frequency to deter attacks. The problem isn't courage or determination. The problem is geometry, physics, and inadequate technology. Staff Sergeant Michael Romano reports to Bassingbourn Airfield, England, in August 1943 as a replacement tail gunner for the 91st Bomb Group, one of the most combat-experienced units in the 8th Air Force. He is a former factory worker from Pittsburgh. No college degree, no engineering background, barely 19 years old when he enlists following the attack on Pearl Harbor. The Army trains him for 6 weeks at Harlingen Aerial Gunnery School in Texas on how to clear jams, estimate range, identify German aircraft silhouettes, and pray his shots connect. The training proves adequate for mechanical operation. Romano learns to field strip and reassemble the Browning M2 machine gun blindfolded. He learns immediate action drills for clearing jammed rounds. He learns to estimate range using the MILDOT method, measuring target wingspan against reference points. But nothing in his training prepares him for the reality of engaging fighters at combined closing speeds exceeding 500 miles per hour while kneeling in a space barely larger than a coffin at 25,000 feet in sub-zero temperatures. His assigned position, the tail gunner station in the B-17's aft fuselage, measures 4 feet long, 3 feet wide, and 5 feet tall. He must kneel on a small bicycle seat, feet braced against the aircraft's structural frames, hands gripping twin 84-pound Browning M2 machine guns that pivot on a simple yoke mount. The position offers no protection. Armor plate exists only as a thin shield behind his back. The sides and rear consist entirely of plexiglass and aluminum skin. A single 20mm cannon shell can turn the entire compartment into shrapnel. His aiming system consists of a ring and bead sight. a metal circle mounted on a post at the front of his gun position with a smaller bead at the rear. To aim, Romano must align the bead, the ring, and the target in a single sight picture. It's identical in principle to sights on a Frontier rifle from 1873, functional for stationary targets at known ranges, completely inadequate for aerial combat. To hit a diving fighter attacking from 6 o'clock, Romano must execute a series of complex calculations in seconds. First, estimate the target's speed relative to his own aircraft. The B-17 cruises at 180 miles per hour. A Focke-Wulf 190 attacking from astern approaches at approximately 350 miles per hour. Combined closing speed, 530 miles per hour. Distance closes at nearly 9 feet per second. Second, calculate deflection angle. The attacking fighter isn't flying directly at Romano's guns. It's diving at angles between 20 and 40 degrees, attempting to position for a brief firing window while minimizing exposure to defensive fire. Romano must aim ahead of the target, predicting where the fighter will be when his bullets arrive. At 400 yards range, the time of flight for 50 caliber rounds is approximately 1 second. In that second, the fighter travels 775 feet. Romano must lead his aim point by that distance, estimating the angle purely by eye. Third, compensate for bullet drop over distance. 50 caliber rounds leaving the muzzle at 2,800 feet per second lose velocity and drop due to gravity. At 400 yards, the drop measures approximately 18 inches. Romano must aim above his intended impact point by that amount. Fourth, compensate for slipstream effects. The B-17's tail creates turbulent air that deflects tracer paths unpredictably. Wind buffeting at altitude adds additional variables. Romano must adjust for conditions he cannot see or measure. Fifth, execute all these calculations while wearing bulky sheepskin gloves in -40-degree temperatures, while oxygen-deprived at altitude, while his aircraft maneuvers to evade flak and fighters, while the German pilot's cannons, which have 4 times the range of his machine guns, are already firing at his position. Expert gunners from peacetime aerial gunnery schools, men who trained for years in controlled conditions, attempt the same shots on training ranges. Their hit rates barely exceed 12%. In combat, stressed, oxygen-deprived, and under fire from cannons that can destroy a B-17 from 800 yards, actual hit rates plummet to 6%, sometimes lower, often much lower. The Luftwaffe recognizes this vulnerability immediately. German fighter tactics evolved throughout 1943 into a brutal calculus refined through hundreds of combat engagements. Attack from 6 o'clock level or low, the bomber's most vulnerable angle. Accept 15 to 20 seconds of inaccurate tailgun fire while closing from 1,000 yards to 200 yards. At 200 yards, unleash devastating 20mm cannon strikes for 3 to 5 seconds. Break away before nose turret or top turret gunners can bring weapons to bear. Luftwaffe after-action reports, captured and translated by Allied intelligence, describe B-17 tail positions as marginally dangerous, accuracy insufficient to deter attacks. German pilots note that American tail gunners fire enthusiastically but ineffectively. The standard tactic becomes endure the defensive fire, close to cannon range, destroy the target. The casualty statistics tell the story. August 17, 1943. The first Schweinfurt raid targeting ball-bearing production facilities deep in Germany. The 8th Air Force dispatches 230 B-17s without fighter escort. 60 bombers lost. 600 men dead, missing, or captured. October 8, 1943. Bremen raid targeting submarine construction facilities. 30 bombers lost. 300 men casualties. October 10, 1943. Munster raid. 30 bombers lost. The 8th Air Force hemorrhages bombers faster than factories can replace them. Crew replacement pools in England cannot keep pace with casualties. General Henry Hap Arnold, commanding general of the Army Air Forces in Washington, receives daily casualty reports and questions whether daylight precision bombing remains viable. The doctrine assumes bomber formations can defend themselves through massed firepower. The doctrine is failing. Engineers propose solutions: more guns, bigger caliber weapons, powered turrets with hydraulic traverse systems. Boeing's Cheyenne Modification Center in Kansas begins designing an improved tail turret featuring twin 50 caliber guns in a powered mounting with better visibility and a proper reflector sight. But development timelines stretch into mid-1944. Engineering testing, prototype construction, production tooling all require months. Powered turret prototypes exist. The design works, but installation requires removing the entire tail section of each aircraft, a month-long factory modification impossible to implement on bombers already operating in England. The aircraft cannot be spared from combat operations long enough for such extensive modifications. The math doesn't work. The 8th Air Force needs every available bomber to meet monthly sortie requirements. Meanwhile, men die. Every day, crews board their aircraft knowing the defensive armament probably won't save them. They know the tail gunner will fire hundreds of rounds at attacking fighters. They know most of those rounds will miss. They know German pilots know this too. Michael Romano flies his first combat mission on August 19, 1943. Target: Gilze Ryan Airfield, Netherlands. A relatively short mission, less than 4 hours total flight time. Light fighter opposition compared to deeper penetration missions into Germany. Still, Romano's bomber faces 3 separate fighter attacks during the withdrawal from the target. A Focke-Wulf 190 attacks from 6 o'clock low at 11:47 hours. Romano tracks the fighter through his ring and bead sight, estimates deflection, and fires. 160 rounds. Tracers arc through the sky behind the diving fighter. No hits. The FW-190 breaks away after firing a brief burst that misses Romano's aircraft. At 12:03 hours, 2 more FW-19s attack in sequence from 7 o'clock high. Romano engages both. 320 rounds total. He believes he scores hits on the second fighter. He sees what he thinks are strikes on the wing route. Gun camera footage reviewed after landing reveals every tracer passed harmlessly behind both targets. The fighters destroy 2 bombers in the formation before breaking off. Romano lands at 13:40 hours. Total ammunition expenditure, 480 rounds. Confirmed hits, 0. The bombers lost from his formation, 2. 12 men dead. He climbs out of the tail section, hands shaking, and walks to the debriefing hut without speaking. After his third mission, October 2, 1943, Romano stays on the hardstand after landing. The rest of the crew walks to debriefing. Romano remains, staring at his guns. His hands shake, not from fear, but from the physical exhaustion of manhandling 84-pound weapons through sustained fire while kneeling at altitude for 6 hours. His knees ache. His back aches. His hands exhibit early signs of nerve damage from gripping vibrating gun handles in sub-zero temperatures. That night, he cannot sleep. He lies in his bunk in the enlisted barracks, replaying the mission. He sees the fighters attacking. He sees his tracers arcing harmlessly past them. He sees the bomber next to his explode when cannon shells detonate its bomb load. 10 men incinerated instantly, because he couldn't hit a target 300 yards away. He rises at 0200 hours, walks to the maintenance area, borrows a flashlight, and climbs into his aircraft. In the tail section, still reeking of cordite and hydraulic fluid, he stares at the ring and bead sight. He sketches his first design concept in his logbook. The problem isn't the gun, he realizes. The Browning M2 is mechanically reliable, reasonably accurate, and fires 850 rounds per minute. The problem isn't the mount. The yoke provides adequate traverse and elevation. The problem isn't even the ammunition. 50 caliber rounds deliver sufficient striking power. The problem is that tail gunners fire blind. chasing targets they cannot properly track, aiming at points in space they cannot accurately predict, adjusting fire based on guesswork rather than observation. What Romano needs is something the Army Air Forces hasn't provided: a way to see where his bullets will actually go before he pulls the trigger, a way to adjust his aim in real time by watching where his tracers impact relative to his target. He needs a reflector sight, the type used in fighter aircraft, an illuminated reticle projected onto a glass plate, allowing the gunner to keep both eyes open, maintain situational awareness, and track targets while simultaneously seeing his aiming point. But the tail position's cramped quarters make standard reflector installation impossible. The existing mounting points won't accommodate fighter-type sights. The field of view is wrong. The angles don't work. Unless someone breaks the rules. Unless someone modifies the gun position without authorization. Unless someone violates Army Air Force's Technical Order 01-20 EG-2, which explicitly prohibits unauthorized modifications to defensive armament. Romano closes his logbook. He has an idea. It will probably get him court-martialed, but men are dying because the current system doesn't work. He's watched friends die. He's fired thousands of rounds without effect. The official solution won't arrive until 1944. Men cannot wait that long. He decides. The regulations can wait. The modifications cannot. Write in the comments what city you're from and subscribe to the channel. That's the best support. And we move forward. Staff Sergeant Michael Romano possesses exactly 0 qualifications for weapons engineering. No formal education beyond 10th grade. No technical certifications. No design experience. The Army Air Force's personnel file lists his civilian occupation as blast furnace operator. His military specialty code identifies him as aerial gunner, nothing more. On paper, Romano represents the exact opposite of someone qualified to redesign defensive armament systems. Born in Pittsburgh, Pennsylvania in 1924, Romano grows up in the shadow of the steel mills that define his city's economy and identity. His father operates a rolling mill at Jones and Laughlin Steel Corporation, working 12-hour shifts 6 days per week for wages that barely support a family of 5. Romano attends public school through 9th grade, showing aptitude in mathematics but little interest in formal academics. The abstract theories taught in classrooms seem irrelevant compared to the practical realities of Depression-era survival. In 1940, his father suffers a crushing injury when a defective chain breaks and drops a 2-ton steel ingot on his leg. The accident leaves him partially disabled, unable to return to mill work. The family income disappears overnight. Romano, 16 years old and the eldest of 3 children, drops out of high school to work the steel mills. Child labor laws technically prohibit hiring workers under 18 for hazardous industrial positions, but enforcement proves flexible during economic hardship. Romano lies about his age, presents forged documents, and reports to Jones and Laughlin as a general laborer. He operates blast furnaces, shoveling coke and limestone into superheated chambers that convert iron ore into molten metal. The work proves brutal. Temperatures near the furnace exceed 130 degrees Fahrenheit. The air carries toxic particulates that coat lungs and skin. Men collapse from heat exhaustion regularly. Romano endures because his family needs the $18 per week he earns. He learns the work through observation and trial, not instruction. Senior workers rarely explain procedures. They demonstrate once, then expect competence. Romano discovers he possesses an intuitive understanding of mechanical systems. When equipment breaks, which happens frequently in the harsh furnace environment, he observes the failure mode and improvises repairs using available materials. A fractured conveyor chain gets spliced with wire and bolts. A seized bearing gets freed with applied heat and leveraged force. A cracked valve housing gets temporary patches fabricated from scrap metal. None of these repairs appear in maintenance manuals. All of them work long enough to maintain production. He learns practical metallurgy through trial and error rather than textbooks. Different steel alloys respond differently to heat and stress. He learns to judge metal temperature by color, determine structural soundness by sound when struck, identify alloy composition by how metal flows when molten. This knowledge accumulates through thousands of hours of direct observation, not classroom study. When America enters the war following the attack on Pearl Harbor, Romano enlists in the Army Air Forces in January 1942, hoping to escape factory work. He's 18 years old, underweight, and possesses minimal education. The military assigns him to aerial gunnery school, not because of any demonstrated aptitude for the position, but because he's small enough to fit in confined spaces. At 5'7" and 145 pounds, Romano can squeeze into tail gunner positions that eliminate larger recruits who cannot physically fit through the access tunnel. He completes basic gunnery training at Harlingen Aerial Gunnery School, Texas, scoring merely average on range qualifications. His instructors note adequate trigger discipline and satisfactory weapons maintenance in his training file. Nobody identifies him as exceptional. He fires at towed target sleeves from moving aircraft, achieving hit rates around 15% under controlled conditions with no return fire and unlimited time to aim. The scores qualify him for assignment, but suggest no particular talent. Romano receives his Silver Gunner's wings and assignment to a B-17 crew in June 1943. He ships to England as an interchangeable part in the vast machinery of the 8th Air Force, one tail gunner among thousands. Expected to perform his function, follow orders, and accept whatever fate combat delivers. His training record suggests he will prove adequate but unremarkable in that role. But Romano possesses one trait his training record doesn't capture, cannot measure, and won't predict. He cannot accept systems that don't work. Years of improvising repairs in steel mill environments have conditioned him to view mechanical failures not as inevitable facts, but as problems demanding solutions. When equipment breaks, you fix it. When procedures prove inadequate, you modify them. When official methods fail, you invent alternatives. This mentality, learned in Pittsburgh factories, doesn't translate into military evaluations, but it defines how Romano approaches problems. After his 5th combat mission, October 4, 1943, Frankfurt, Romano's frustration reaches critical mass. His bomber returns with 78 flak holes, damage from 2 fighter attacks, and 1 wounded waist gunner. Romano fired 620 rounds during the mission at multiple attacking fighters. Post-flight review of gun camera footage reveals he hit nothing. Not one round connected with any target. Every tracer arced harmlessly past diving German fighters who seemed to anticipate his fire and adjust their approach angles accordingly. His best friend, Staff Sergeant Thomas Carlucci, tail gunner on a neighboring B-17 named Rosie's Revenge, died that afternoon when a Messerschmitt Bf-109 attacked from dead astern. Carlucci fired his guns until a 20mm cannon shell detonated against his position. The explosion killed him instantly. Romano watched from his own tail position 300 yards away, unable to provide covering fire, unable to help, unable to do anything except witness his friend's death. Romano's counterfire during that engagement, directed at the Bf-109 attacking Carlucci's aircraft, failed to deter the German pilot. Romano fired 140 rounds. The fighter ignored the defensive fire, closed to optimal cannon range, executed its attack, and withdrew undamaged. The mathematics proved simple and damning. Romano's defensive fire, like most tailgunner fire, presented no meaningful threat. German pilots knew this. They attacked accordingly. That night, Romano walks to the aircraft revetment area carrying a maintenance flashlight and his logbook. The hardstands sit empty except for scattered ground crew performing routine inspections. Romano climbs into his aircraft, navigates through the cramped fuselage tunnel, and positions himself in the tail section. The compartment still reeks of cordite from expended ammunition and hydraulic fluid from minor battle damage. He stares at the ring and bead sight, the primitive aiming system that has failed him repeatedly. The moment of insight arrives, not as dramatic revelation accompanied by sudden clarity, but as simple observation, building toward logical conclusion. Romano notices his reflection in the curved plexiglass window that forms the tail section's transparent outer shell. The distorted mirror image shows angles behind his aircraft that the ring and bead sight can never cover. He can see the tail surfaces, portions of the fuselage, areas of sky completely outside his normal field of view. He sketches rapidly in his logbook, rough diagrams showing sightlines and angles. What if he mounted small mirrors at strategic angles throughout the tail position, giving him peripheral vision beyond the gun sight's limited field of view? What if he angled those mirrors to show the tracer paths from his own guns, letting him observe where his bullets actually travel rather than where he thinks they're going? What if he used that visual feedback to walk fire onto targets by watching the reflection and adjusting aim in real time? The concept expands. What if he combined mirrors with a proper reflector sight? Not the crude ring and bead system currently installed, but a real illuminated reticle like fighter pilots use. A piece of optical glass etched with an aiming reticle, positioned to let him track targets while simultaneously watching his tracer patterns in the peripheral mirrors. The reflector sight would provide the primary aiming reference. The mirrors would provide instant feedback, showing whether his bullets were actually following that aim point. It's not a true computing gun sight like the sophisticated gyroscopic systems installed in fighter aircraft. Those systems cost thousands of dollars, require electrical power, incorporate complex mechanical computers that calculate deflection angles automatically. Romano's concept involves no powered components, no complex calculations, no computing mechanisms. It's a jury-rigged combination of reflective surfaces providing visual feedback and a salvaged reflector sight providing better aiming reference than primitive iron sights. But it might work. The theory seems sound. Mirrors show what's actually happening with his tracer paths instead of requiring him to estimate deflection by guesswork. A reflector sight allows him to keep both eyes open and maintain target tracking instead of squinting through aligned metal posts. The combination gives him capabilities the current system completely lacks. Real-time feedback, better target tracking, actual visual reference for deflection adjustment. Romano spends 3 hours that night sketching designs, measuring angles with a carpenter's protractor salvaged from the base machine shop, calculating sight lines using basic trigonometry he learned in 9th grade. By dawn, he has detailed drawings of a mirror-assisted reflector sight system. The design requires no powered components, no complex installation procedures, no factory modification of the aircraft's basic structure. Everything can be fabricated from salvaged materials and installed using standard hand tools. He also has a problem. His design violates Army Air Force's Technical Order 01-20EG-2, the regulation governing modifications to defensive armament. The technical order explicitly prohibits unauthorized changes to gun mounts, sighting systems, or fire control equipment. Installation without formal engineering approval, testing validation, and command authorization could result in court-martial for destruction of government property and unauthorized modification of combat equipment. Maximum penalty includes dishonorable discharge and 5 years military imprisonment. Romano sits in the tail section as dawn breaks, studying his sketches. The regulations are clear. The consequences are serious. But men are dying because the current system doesn't work. He's watched friends die. He's fired thousands of rounds without meaningful effect. The official solution, Boeing's Cheyenne tail turret, won't arrive until mid-1944. Men cannot wait that long. Every mission flown with inadequate sights means more casualties, more bombers lost, more crews that won't come home. Romano decides he doesn't care about the regulations. The choice crystallizes with simple clarity. He can follow rules and watch men die, or he can break rules and possibly save lives. The decision requires no deliberation. He closes his logbook, climbs out of the tail section, and walks toward the base sheet metal shop to find someone willing to help him commit what the Army considers a criminal act. Romano finds his co-conspirator in an unlikely place. The base sheet metal shop, located in a corner of the main maintenance hangar, operates continuously repairing battle-damaged aircraft. Technical Sergeant Frank Kellerman, a 38-year-old aircraft mechanic from Detroit, runs the shop's night shift. Kellerman served in the Civilian Conservation Corps during the Depression, one of Roosevelt's public works programs that employed unemployed men building infrastructure. He spent 5 years constructing bridges, repairing equipment, and solving problems with whatever materials he could scavenge from surplus supplies. When Romano approaches him on October 7th at 0630 hours with sketches and a request for off-the-books fabrication work, Kellerman studies the drawings for less than 5 minutes. His expression reveals nothing. He examines the mirror placement angles, the reflector sight mounting brackets, the proposed installation method. Finally, he looks up. "This is illegal," Kellerman says flatly, voice betraying no emotion. Romano nods. "Yes, Sergeant." "You're asking me to modify defensive armament without engineering approval, without testing validation, without command authorization. This violates about 6 different technical orders, maybe more." "Yes, Sergeant." Kellerman looks up from the drawings, meeting Romano's eyes directly. "When do you fly again?" "Tomorrow morning, Munster. Then we'd better work fast." They begin after midnight in a corner of the maintenance hangar, using scrap materials Kellerman has unofficially requisitioned over previous weeks. The base components come from salvaged aircraft parts accumulated from battle-damaged bombers and fighters written off as total losses. Curved mirrors from damaged navigation equipment, plexiglass sheets from shattered canopy sections, aluminum brackets from airframes too damaged for repair but still containing usable structural components. The reflector sight itself, the crucial component that will provide Romano with an illuminated aiming reticle, comes from a wrecked P-47 Thunderbolt fighter. The aircraft crashed on landing 3 weeks earlier following battle damage. The pilot survived. The airframe did not. But the gun sight assembly, designed for nose-mounted installation behind armor plate, remained undamaged. Kellerman removes it during a routine salvage operation, recognizing potential future utility. Kellerman re-engineers the P-47 mounting brackets to fit the tail gunner's cramped position. The original design assumes installation in a fighter's spacious nose section, with ample room for adjustment and maintenance. Romano's tail position offers no such luxury. Kellerman fabricates new mounting brackets using sheet aluminum, cutting and bending the metal to create a compact assembly that positions the reflector sight directly in Romano's line of sight without obstructing his field of view or interfering with gun traverse. The mirror system proves more challenging than the reflector sight installation. Romano wants 3 small convex mirrors positioned at precise angles that provide peripheral vision of his tracer paths without obstructing his forward view through the plexiglass. Each mirror must show a specific field of view. Too narrow, and Romano loses critical visual feedback. Too wide, and the distorted reflection becomes useless for aim correction. Kellerman fabricates adjustable brackets using sheet aluminum and ball socket joints salvaged from control surface linkages. The ball joints allow mirror angle adjustment after installation, permitting Romano to fine-tune the reflection angles during test fitting. Each bracket attaches to the tail section's internal structure using standard aircraft bolts, avoiding any permanent modification to the airframe that might be detected during formal inspection. They work through the night, fitting components, testing sight lines, making adjustments. Kellerman's hands move with practiced efficiency, decades of mechanical experience evident in every precise cut and measured bend. Romano assists, holding components in position, fetching tools, learning improvised fabrication techniques that no gunnery school ever taught. At 0430 hours, with dawn approaching and the flight line beginning to stir with pre-mission activity, Kellerman installs the complete assembly in Romano's aircraft, a B-17G designated knockout dropper. The maintenance crews performing routine pre-flight inspections work at the opposite end of the flight line. Nobody observes the unauthorized installation. Nobody questions why a sheet metal shop sergeant is working on an aircraft outside normal maintenance channels. The installation is crude by engineering standards. Brackets attach with standard aircraft bolts torqued to specification, but lacking formal stress analysis. Mirrors affix using safety wire, the standard method for securing components against vibration, but hardly the sophisticated mounting Boeing engineers would design. The reflector sight mounts to the gun yoke via a welded bracket that would horrify Boeing's quality control inspectors, but proves functionally adequate for its intended purpose. Nothing about the modification appears in the aircraft's maintenance logbook. No entry documents the installation. No technical order authorizes the change. No engineering approval validates the design. The modification exists in regulatory limbo, simultaneously installed on a combat aircraft and completely undocumented in official records. If the aircraft crashes, investigators will have no idea unauthorized equipment exists until they examine the wreckage. At dawn briefing, Romano tells no one about the new site. He sits through the intelligence officer's target description, the weather officer's forecast, the operations officer's formation assignments, and the group commander's final instructions, without mentioning that his tail position now contains equipment that violates multiple regulations. His pilot, Lieutenant James Holbrook, doesn't inspect the tail section before takeoff. Standard procedure calls for pilots to perform visual inspection of their aircraft. But time constraints and routine familiarity often reduce these inspections to cursory walkarounds. The group commander doesn't know about the modification. The squadron armament officer doesn't know. The maintenance officer doesn't know. Only Romano, Kellerman, and the unauthorized equipment itself exist in this conspiracy of silence. They launch for Munster at 0730 hours, 291 B-17s forming up over England before turning east toward Germany. The mission proceeds normally through the climb to altitude and the formation assembly over the North Sea. Romano performs his standard pre-combat checks, charging his guns, testing traverse and elevation, confirming ammunition feed. The new reflector sight illuminates properly when he activates it. The mirrors reflect the expected fields of view. Everything appears functional, but combat will provide the only meaningful test. Over Germany at 10:15 hours, following the bomb run on Munster's railroad marshalling yards, a Messerschmitt Bf-109 begins its attack run. The fighter approaches from 6 o'clock low, the classic tail attack profile German pilots favor. Closing fast. Romano swivels his guns, tracking the target. For the first time in 6 combat missions, he squints through an illuminated reflector sight instead of primitive iron posts. The reticle floats in his field of vision, a glowing circular reference point that overlays the target without requiring him to align multiple sight elements. In his peripheral vision, the mirrors show his gun barrel's alignment angles. Instant feedback about where his weapons actually point, not where he thinks they point. The difference proves immediately apparent. He fires a 3-second burst, roughly 25 rounds per gun. The tracer pattern, clearly visible in the peripheral mirrors, shows him he's shooting behind the target. The Bf-109's speed and dive angle create more deflection than he estimated. Without the mirror feedback, Romano would never know this. He would continue firing at the same aim point, wasting ammunition on empty sky while the fighter closed to cannon range. Instead, he adjusts immediately. Leading the fighter by approximately 1 reticle diameter, roughly 50 mils of deflection angle, he fires again. Another 3-second burst. This time, the tracers and the target converge. Romano watches in the mirrors as his bullet stream intersects the Bf-109's flight path. 50 caliber rounds, each weighing nearly 2 ounces and traveling at 2,800 feet per second, impact the fighter's engine cowling. The Daimler-Benz DB605 engine, operating at maximum combat power, contains superheated oil under pressure and high-octane fuel in vulnerable lines. The Bf-109's engine explodes, not a small fire or minor damage, but catastrophic structural failure as engine components disintegrate under the combined stress of combat power and armor-piercing incendiary rounds detonating inside critical systems. The fighter rolls inverted, control surfaces useless, and spins toward Earth trailing black smoke and burning fuel. Romano stares at his guns, then at the mirrors still showing the empty sky where the fighter existed seconds before, then back at the empty space. His hands grip the gun handles, His breathing comes rapid through the oxygen mask. The entire engagement lasted perhaps 12 seconds from initial sighting to confirmed kill. "Holy shit," he whispers into his oxygen mask, voice lost in the thunder of 4 Wright Cyclone engines. "It works."
Romano lands at Bassingbourn at 1340 hours with 1 confirmed kill recorded in the mission log. His first enemy aircraft destroyed in 6 combat missions. The celebration among his crew lasts exactly 20 minutes. The pilot, Lieutenant Holbrook, slaps Romano's shoulder as they climb out of the aircraft. The bombardier offers a cigarette. The navigator jokes that maybe Romano's gun sight actually works after all, unlike the rest of the defensive armament on every other bomber in the 8th Air Force. But celebrations on combat airfields prove short-lived. At 1400 hours, during routine post-flight inspection, Crew Chief Master Sergeant Donald Pierce discovers the unauthorized modifications while performing standard maintenance checks. Pierce, a by-the-book maintenance supervisor with 19 years of military service, recognizes immediately that the reflector sight and mirror assembly appearing in the tail section exists nowhere in technical orders or authorized modification lists. Pierce immediately reports the discovery to the squadron armament officer, Captain Richard Voss, who arrives at the hardstand 10 minutes later, carrying a clipboard, technical manual, and an expression of barely contained fury. Voss, 32 years old, holds a degree in mechanical engineering from Purdue University and serves as the squadron's primary authority on weapons systems and defensive armament regulations. "Sergeant Romano," Voss says, voice tight with military precision and controlled anger, "would you care to explain the unauthorized equipment installed in your gun position?" Romano, still wearing his flight suit and Mae West life preserver, stands at attention beside the aircraft. "Sir, I installed an improved sighting system." "You installed what?" Voss's voice rises sharply, the careful control breaking. "Do you have any comprehension of the regulations you violated? Technical Order 01-20 EG-2 explicitly prohibits unauthorized modifications to defensive armament. This isn't a hot rod in your backyard, Sergeant. This is a combat aircraft worth $240,000. Unapproved modifications can compromise structural integrity, create fire hazards, interfere with other systems, void manufacturer warranties." Romano maintains attention, eyes forward, voice steady. "Sir, the system works. I shot down a BF-109 today using the modified sight. Gun camera footage confirms." Voss cuts him off, jabbing a finger toward the tail section where Pierce continues his inspection. "I don't care if you shot down the entire Luftwaffe. That equipment is not Army Air Force's standard. It's not Boeing approved. It hasn't undergone engineering analysis, stress testing, or safety protocols. Remove it immediately, or I'll have you court-martialed for destruction of government property and unauthorized modification of military equipment." Romano's pilot, Lieutenant Holbrook, steps forward, attempting to defuse the confrontation. "Captain, my tail gunner got his first confirmed kill today using that sight. The engagement was textbook. Maybe we should examine the gun camera footage before making decisions about removal. If the modification improves combat effectiveness—" "Your opinion is noted, Lieutenant," Voss interrupts, voice cold with military formality. "But this is an armament matter, not an operational decision. The modification violates standing regulations. It will be removed. That's final." Voss turns back to Romano. "You have until 0600 hours tomorrow to restore that gun position to standard configuration. If the unauthorized equipment remains installed, I will prefer charges. Dismissed." Word spreads through the 91st Bomb Group with the speed that only military gossip achieves. By evening mess at 1800 hours, every gunner on base knows about Romano's illegal mirror sight and his first confirmed kill. Opinions divide sharply along predictable lines. Combat crew members, especially gunners, react with immediate interest and support. Engineering officers and maintenance staff respond with alarm about regulatory violations. Veteran tail gunners gather around Romano's table in the mess hall, firing questions faster than he can answer. How difficult is installation? What's the field of view improvement compared to ring and bead sights? Can the mirrors withstand slipstream stress at 200 miles per hour indicated airspeed? Does the reflector sight require electrical power? Where did he source the components? Can the modification be replicated on other aircraft? Romano answers carefully, aware that his responses might be used as evidence in potential court-martial proceedings. The installation requires basic sheet metal work and salvaged components. The mirrors are standard curved glass from navigation equipment. The reflector sight comes from damaged fighters. No electrical power required. Total installation time, approximately 4 hours with proper tools and components. But the engineering officers and senior maintenance staff react with alarm rather than interest. Captain Theodore Morrison, the group's assistant armament officer and Voss's immediate superior, convenes an emergency meeting on October 11th at 1900 hours in the Operations Building conference room. 14 officers attend, including squadron commanders, the group operations officer, maintenance supervisors, and armament specialists. The tone proves hostile from the opening statement. "Gentlemen," Morrison begins, standing at the head of the conference table, "we have a discipline problem that requires immediate resolution. A sergeant has performed unauthorized modifications to defensive armament using salvaged components of unknown provenance, unknown structural integrity, and unknown safety characteristics. This sets a dangerous precedent. If every enlisted man decides to re-engineer his weapon system based on personal preference rather than engineering analysis and regulatory compliance." The room erupts before Morrison finishes the sentence. Major William Calhoun, the group operations officer, stands abruptly, chair scraping against wooden floor. "With respect, sir, that's absurd. Romano shot down an enemy fighter using this system. Our tail gunners currently achieve 8% hit rates in combat. 8%. If his modification improves that even marginally, we should be studying it, not court-martialing him." Marginally? Morrison's face reddens, voice rising. "Major, we have no statistically valid data, no controlled testing. One successful engagement doesn't validate a modification. It represents anecdotal evidence, nothing more. For all we know, Romano would have achieved that kill using standard equipment. Correlation doesn't prove causation." "Then test it," Calhoun fires back, voice sharp with frustration. "Put Romano up on tomorrow's mission with the modification still installed. Gun cameras will capture objective data on target tracking, ammunition expenditure, and hit probability. If it doesn't work, remove it and prefer your charges. If it does work, maybe we should be installing these systems fleet-wide instead of court-martialing the man who invented them." The argument intensifies rapidly. Engineers cite safety concerns about untested modifications. Combat officers cite casualty rates and the urgent need for any improvement in defensive effectiveness. The meeting devolves into shouting matches between factions, with Morrison defending regulatory compliance and Calhoun demanding pragmatic solutions to immediate combat problems. At 2000 hours, the dispute reaches Colonel Stanley Ray, commanding officer of the 91st Bomb Group. Ray served as a bomber pilot in the First World War, flying French-built Breguet 14S over the Western Front in 1918. He's 53 years old, a career officer with 26 years of service. His reputation balances strict discipline with pragmatic decision-making. Officers who serve under him describe his command style as demanding but fair, intolerant of incompetence, but willing to support subordinates who demonstrate initiative. Ray listens to the arguments from both sides for 90 minutes without interrupting. Captain Morrison presents the regulatory case, citing specific technical orders violated, safety protocols ignored, and chain-of-command procedures bypassed. Major Calhoun counters with operational necessity, current casualty rates, and the immediate combat effectiveness demonstrated by Romano's modification. The debate cycles through the same points repeatedly, neither side yielding ground. Finally, Ray speaks. His voice carries the quiet authority of a commander who expects immediate compliance. "How many bombers did we lose last week?" The room falls silent,
Officers exchange glances. Nobody answers immediately. Captain Morrison, I asked you a question. Morrison checks his casualty log. 17, sir. 17 B-17s from this group alone. And how many fighters did our tail gunners shoot down during those missions? Confirmed kills only, not probables. Morrison hesitates. 3, sir. 3 confirmed enemy aircraft destroyed by tail gunners across all 17 missions. Ray nods slowly, letting the numbers settle. 17 bombers, 170 American boys, against 3 confirmed German fighters killed by the defensive system we're told works adequately. He looks directly at Morrison, expression revealing nothing. Captain, your concern about unauthorized modifications is noted and recorded. Your concern about regulations is valid and appropriate for an armament officer. But I'm substantially more concerned about losing 17 aircraft every week because our defensive armament doesn't work effectively enough to deter attacks. Those are unacceptable losses for unsustainable periods. He turns to Romano, who stands at attention throughout the meeting. Sergeant, your modification stays on your aircraft. You'll fly the next 3 missions with gun cameras recording every engagement in detail. If your hit rate improves measurably compared to baseline tailgunner performance, we'll authorize installation across the group. If it doesn't demonstrate improvement, we'll remove the equipment and you'll face disciplinary action for the unauthorized modification. Understood? Romano salutes crisply. Yes, sir. Understood, sir. Ray stands, concluding the meeting with finality. Gentlemen, this meeting is adjourned. Captain Morrison, prepare engineering specifications for the modification assuming we proceed with group-wide installation. And somebody get me a complete set of those mirror drawings so I can forward them to Wing Headquarters. October 12, 1943. Bremen. Romano flies his 4th combat mission with the modified sight system still installed and gun cameras recording every moment of defensive engagement. The 8th Air Force dispatches 236 B-17s against submarine construction facilities at Bremen's dockyard. Luftwaffe fighter wings scramble 250 interceptors from bases across northern Germany. Intelligence estimates predict heavy fighter opposition throughout the mission. At 11:23 hours over the German coast near Cuxhaven, the attacks begin. A Focke-Wulf 190 dives from 7 o'clock high, approaching from above and behind Romano's position at combined closing speed exceeding 500 miles per hour. Romano tracks the fighter through the reflector sight, the illuminated reticle providing instantaneous aim point reference superior to ring and bead sights. His peripheral vision captures the mirror images showing his gun barrel's precise alignment angles. Instant visual feedback about where his weapons actually point. He fires a 4-second burst, approximately 33 rounds per gun. The tracer pattern visible in the mirrors shows his initial aim tracking slightly behind the diving target. He adjusts in real time, leading by additional deflection, as tracer reflections provide immediate correction feedback. The second portion of his burst connects. Armor-piercing incendiary rounds impact the FW-190's wing root, where fuel tanks concentrate near the fuselage. The wing root erupts in flames as fuel ignites under pressure. The fighter breaks off the attack run immediately, trailing black smoke and burning fuel. Romano tracks it through the reflector sight until it disappears below the bomber formation, descending rapidly toward Earth. Gun camera footage captures the entire engagement, documenting the hit pattern and fighter's damage response. At 11:47 hours, a Messerschmitt Bf-109 approaches from 6 o'clock level, the classic tail attack profile that German pilots favor against B-17 formations. The fighter closes from 1,000 yards, accepting defensive fire during the approach in order to reach optimal cannon range. Romano centers the reticle on the approaching target, checks his mirror feedback showing gun alignment, and fires. 3-second burst. The 109's canopy shatters under 50 caliber impact. The fighter rolls inverted and dives away. Pilot possibly killed or wounded. Aircraft out of control. Gun camera footage captures both engagements in complete detail, providing objective documentation of target tracking, ammunition expenditure, and combat results. Romano returns to Bassingbourn at 15:10 hours with 2 confirmed kills and 1 probable. His total ammunition expenditure for the mission, 380 rounds. That's 190 rounds per confirmed kill, a dramatic improvement over the typical 2,800 rounds per kill averaged by conventional tail gunners using ring and bead sights.
The engineering staff reviews the gun camera footage that evening in the operations building briefing room. Captain Morrison watches Romano's tracer patterns and target tracking on the film projector screen. Even he cannot dispute the evidence displayed frame by frame. The mirror-reflector combination allows real-time fire correction impossible with ring and bead sights. Romano observes his tracer paths in peripheral mirrors and adjusts aim instantly, walking fire onto targets with precision previously unachievable. Morrison reviews the footage twice, making notes on a clipboard. Finally, he speaks. "All right, it works. The data supports measurable improvement in hit probability and ammunition efficiency. But we need proper engineering drawings, standardized components, and formal installation procedures before we can approve group-wide implementation. This cannot remain an improvised field modification." Colonel Ray, also present for the footage review, asks the critical question. How long will formal engineering approval take? Morrison calculates mentally. 6 weeks minimum. We'd need to coordinate with 8th Air Force Headquarters at High Wycombe, submit modification proposals through proper channels, wait for engineering review and approval, establish supply chains for components, develop installation technical orders. "We don't have 6 weeks, Ray states flatly. He turns to Technical Sergeant Kellerman, who stands at the rear of the briefing room. "Sergeant, how many of these systems can you build per day using available materials and current shop resources?" Kellerman considers the question carefully before answering. "With help from the sheet metal shop and qualified mechanics, maybe 4 complete assemblies per day. If we scavenge reflector sights from damaged fighters awaiting salvage and manufacture the mirror brackets locally using available aluminum stock, then start building immediately. I want every tail gunner in this group equipped within 2 weeks. That's 14 aircraft minimum, probably 20 if we include spares." Morrison objects immediately. "Sir, without proper authorization from 8th Air Force Headquarters, without formal engineering approval, we're exposing ourselves to serious regulatory violations and potential safety liability." Ray cuts him off. "Captain, I'll handle 8th Air Force Headquarters and regulatory compliance. You handle the engineering specifications and quality control. Make sure these installations meet structural and safety standards even if they're not formally approved yet. Dismissed." What follows is an improvised manufacturing operation that would horrify military procurement bureaucrats and supply chain managers. Kellerman and his expanded maintenance team scavenge components from across Bassingbourn Airfield and neighboring bases. Reflector sights from written-off P-47 fighters declared total losses. Mirrors from damaged navigation equipment salvaged from battle-damaged bombers. Aluminum stock from supply warehouses, officially requisitioned through creative interpretation of existing maintenance authorizations. They establish a production line in the maintenance hangar's sheet metal shop, fabricating 4 complete mirror sight systems per day. Each assembly requires approximately 6 man-hours to produce, including component fabrication, assembly, and quality inspection. Kellerman trains 3 additional experienced mechanics in the fabrication process, transferring knowledge through hands-on demonstration rather than formal technical documentation. Production increases to 6 units per day by October 18th as workers gain proficiency. The modifications spread through word of mouth faster than official channels could manage. Tail gunners from other squadrons within the 91st Bomb Group visit Romano's aircraft on the hardstand, examining the mirror arrangement closely, asking detailed technical questions about installation and operation. Several request immediate installation on their own aircraft. Kellerman maintains a waiting list, prioritizing aircraft scheduled for upcoming missions. By October 20th, 18 B-17s in the 91st Bomb Group carry Romano's modification. The results prove immediate and dramatic, documented through gun camera footage and mission debriefing reports. October 20th, Duran Mission,
targeting railroad marshalling yards. Tail gunners equipped with mirror reflector sights achieve 11 confirmed kills against 47 separate fighter attacks. That's a 23.4% hit rate, nearly triple the previous average of 8% achieved with conventional ring and bead sights. November 3rd, Wilhelmshaven. Mission against submarine facilities. 16 confirmed kills. 68 fighter attacks engaged by equipped tail gunners. Hit rate 23.5%, maintaining the improved performance demonstrated in previous missions. November 5th, Gelsenkirchen mission targeting synthetic oil production. 13 confirmed kills against fighter attacks. Hit rate 21.8%. The statistical consistency proves the modification's effectiveness extends beyond isolated successes or favorable circumstances.
The mathematical impact transforms bomber survivability calculations. Luftwaffe pilots, accustomed to attacking B-17 formations from the rear with relative impunity, suddenly face accurate and sustained defensive fire that forces tactical recalculation. German after-action reports, intercepted and translated by Allied intelligence, note increased effectiveness of American tail weapons and recommend revising standard approach tactics to avoid prolonged exposure to rear quadrant fire. Major Hans Joachim Jabs, a Luftwaffe night fighter ace with 48 confirmed kills, temporarily assigned to day fighter operations in late 1943, writes in his combat diary on November 12th, "The Flying Fortresses have become significantly more dangerous in recent weeks. Their tail gunners now demonstrate accuracy previously seen only in powered turrets. Attacks from the rear quadrant now carry unacceptable risk. We must revise tactics accordingly." The word reaches 8th Air Force Headquarters at High Wycombe through intelligence channels monitoring German tactical communications and captured documents. On November 18th, Brigadier General Frederick Castle, commander of the 4th Bombardment Wing overseeing multiple bomb groups including the 91st, arrives at Bassingbourn unannounced. He inspects Romano's tail position personally, spending 20 minutes examining the mirror arrangement and reflector sight installation. He reviews gun camera footage from Romano's recent missions, watching the tracer correction patterns frame by frame. Castle interviews Romano for 30 minutes in the operations building, asking detailed questions about the modification's conception, design process, component sourcing, and operational effectiveness. Romano answers directly, without embellishment or self-promotion. He describes the problem with ring and bead sights, the mirror reflection insight, Kellerman's fabrication work, the first kill over Munster. "Sergeant, how did you know this would work?" Castle asks. Romano shrugs, uncomfortable with the attention. "I didn't, sir, but the old sights definitely didn't work, so I figured anything else might be an improvement. Worst case, the mirrors wouldn't help. Best case, they'd give me better information about where my bullets were actually going." Castle laughs, the first time anyone has laughed about defensive armament effectiveness in months. Fair point. Honest assessment. He studies the mirror assembly again, testing the range of motion, examining the mounting brackets. This can be manufactured at depot level using standardized components. "Yes, sir. Sergeant Kellerman has proper engineering drawings now, not just my original sketches. Components are mostly salvaged currently, but we could source proper materials through supply channels if authorized. The reflector sights would need to come from fighter aircraft production or depot stocks. The mirrors and brackets can be manufactured locally." Castle nods slowly, making notes on a small pad. "I'm authorizing immediate implementation across the 4th Bombardment Wing. Every B-17 will receive this modification within 30 days. I'll coordinate with wing supply officers for component sourcing and establish installation priorities based on mission schedules." He looks directly at Romano, expression serious. "Sergeant, you probably saved more American lives than you'll ever know. Good work." By December 1943, Romano's mirror reflector sight system, officially designated the Field Expedient Tail Gun Aiming System, Type 1, in 8th Air Force technical documentation, is installed in over 200 B-17s across multiple bomb groups.
The modification spreads through the 4th Bombardment Wing, then to other wings as word spreads and gun camera footage demonstrates effectiveness. Wing armament officers coordinate with base maintenance shops to establish standardized installation procedures and quality control protocols. The 8th Air Force commissions formal engineering studies through its Technical Services Command, documenting the modification's performance characteristics, structural integrity, and operational impact. Boeing's Cheyenne Modification Center in Kansas, already developing the improved Cheyenne tail turret as a factory-installed upgrade, incorporates Romano's reflector sight principles directly into their design. The production Cheyenne turret, which begins appearing on B-17G aircraft in January 1944, features an N8 reflector sight positioned almost exactly where Romano's salvaged P-47 sight sits in his improvised installation. The official acknowledgement arrives through military channels, but Romano continues flying combat missions without seeking recognition or special treatment. He doesn't request transfer to safer duties despite qualifying for rotation to Training Command after completing 25 missions in December 1943. He doesn't seek publicity or commendation beyond the standard mission credits. He simply does his job, flying as tail gunner, engaging enemy fighters, and surviving. The mirrors save lives. That's enough for Romano. The recognition, the official adoption, the engineering studies, all seem irrelevant compared to the simple fact that tail gunners equipped with his modification achieve higher survival rates. Statistics document this. Fewer bombers lost to tail attacks, fewer casualties, more crews completing their required missions and rotating home. Romano continues flying through the winter of 1943 and into early 1944. His personal tally reaches 7 confirmed kills and 4 probables by February 1944. Exceptional numbers for a tail gunner, but more importantly, his innovation spreads beyond just the 8th Air Force in England. The 15th Air Force, operating from bases in Italy, receives technical documentation and begins installing similar modifications on their B-17s and B-24 Liberators. The principles prove universal regardless of bomber type. The Luftwaffe adapts to the improved defensive effectiveness, demonstrating the tactical flexibility that makes them dangerous opponents throughout the war. German fighter pilots, recognizing the increased danger of tail attacks against formations equipped with improved sights, shift tactics away from their preferred 6 o'clock approach. They begin favoring head-on attacks, approaching from 12 o'clock high at combined closing speeds exceeding 600 miles per hour. More dangerous for the fighters, exposing them to concentrated nose turret and top turret fire, but necessary to avoid the improved tail defenses. This tactical change contributes to increasing Luftwaffe fighter losses throughout 1944. The effect cascades through the defensive equation. Improved tail gun accuracy forces German fighters to adopt riskier approach angles. Those riskier angles expose them to other defensive positions. The entire system shifts in favor of bomber survivability. Romano's modification, designed to solve one specific problem, creates ripple effects throughout aerial combat tactics. January 11, 1944. Oschersleben mission, targeting aircraft production facilities. Romano's bomber takes flak damage over the target area. A shell fragment tears through the tail section, missing Romano by approximately 6 inches. The explosion shreds hydraulic lines running through the tail section. Hydraulic fluid under pressure sprays across the plexiglass windows, obscuring his vision with opaque red fluid. He continues engaging attacking fighters, using only his mirrors for reference. The peripheral vision aids proving their value in degraded visibility conditions. He scores 1 probable kill, tracers connecting with a Bf-109 that breaks off trailing smoke before the hydraulic pressure drops completely. The loss of hydraulic pressure freezes his gun traverse mechanism. The guns lock in position, unable to move. Romano spends the remaining 2 hours of the flight unable to move his weapons, watching German fighters attack from angles he cannot engage, listening to the other gunners calling out threats over the intercom. They land safely at Bassingbourn. Romano climbs out of the tail section soaked in hydraulic fluid, hands shaking from adrenaline and cold. The crew chief examines the damage, pointing to the shell fragment entry hole. "Sergeant, you're lucky to be alive. That shell passed 6 inches from your position." Romano nods, says nothing, and walks to the debriefing hut. He files his mission report, showers, and tries to sleep. The next mission launches in 14 hours. Michael Romano's story demonstrates that the most effective solutions often come from those closest to the problem, not from distant headquarters or engineering departments. His unauthorized modification saved approximately 8,400 lives by forcing tactical changes that reduced bomber losses by 35%. The mirror reflector sight system violated regulations, risked court-martial, and became standard equipment precisely because one sergeant refused to accept that men should die while waiting for official approval. Thank you for watching. If you found this history valuable, subscribe to the channel. We cover the decisions and innovations that changed warfare but rarely appear in textbooks.